Good morning, dear students. I just want to tell you about the exam. Exam is on Wednesday, next Wednesday, at 2 o'clock, 2 to 3. And the portion for the exam is chapter 1 and 2. Okay. I uploaded the notes, right? For chapter 1 and 2. Right?
Yes.
Did you see? Yeah, okay.
So, Doctor, the portion that we had on Sunday from chapter 3 is not going to be included?
It's not there. It's not there.
Okay.
Okay, that I'll keep for the next exam. Okay, so I think I finished this geometrical isomerism part, but I didn't give an example with, did we do this question number 6 and 7? I don't think so, right? The remaining questions I explained which all things undergo, I mean like geometrical isomerism, right? I explained geometrical isomerism, no?
Yes.
Yeah, okay. So now, the next question is about butene. But 1 in and but 2 in, which one shows geometrical isomerism? Any idea? And you need to draw the geometrical isomers. Okay, you need to know how to draw it. Okay, because in the exam all the questions are not multiple choice. Look, but 1 in. What's the formula? C. Okay, 1 in is this, right? Correct?
Yes.
So satisfy the valency. So it will be CH3, CH2, CH2. So does this show geometrical isomerism?
No.
Why? Sorry?
It's all H.
Yes, because here 2 hydrogen atoms, 3 groups are the same. If 3 groups are same, it doesn't show. Okay, so it does not. Now, butene, we go for butene and let's see. C. Okay, this is butene, satisfy the valency, CS3, CH, CS3. Does this show? Are you sleeping, my dears?
No, Doctor, I'm thinking.
Sorry?
No, we're here, Doctor.
You don't.
Yes, it shows geometrical isomerism.
It shows. What's your name, my dear?
Safwan.
Safwan. Safwan is telling it shows. Others? Okay, let's see whether we can draw or not. Just focus on these 2 carbon atoms. C double bond C. And one group is CH3. Another group is H. Say, I write H here, CH3 here. Then the other side, again, we have one CH3 and H. H, CH3. This is. So, this is which isomer? This is which isomer?
Cis.
So, how do you make trans? Keep one of them same. First one same and switch the other 2. So, what do you get? CS3 here, H here. So, this is which isomer? Trans. First one is cis, second one is trans. Did you understand? You want more examples?
Please, yes.
Okay, see, suppose if it is pent 2-ene, okay? Or instead of pent, I'll write hex 3, hex 3-ene, or 2-ene, say 2-ene. So how do you do it? 1, 2, 3, 4, 5, 6, okay? 2Ne means here. Satisfy the valency. CH3, CH, CH. This will be CH2, CH2, CH3. Now, come on, come on. Focus on this one. Focus on these two. Now, one side it's H, the other side it's CH3. Next side this group, the other one this one. So, right?
Yes.
So how do you do it? C double bond C. Tell me.
On the first one, there's a CH3 group
There
and
is
that.
one H and CH3. You can. There is no rule H up CH3 down. You can do anything. The other side, say I put H and the other group CH2, CH2, CH3. Right? You understand what I did?
Yes.
Yes.
Okay. Now, possible or not?
It's possible because there are two identical groups on different carbons.
Yes, my dear, correct. So this is okay. And switch the other two, CH2, CH2, CH3. Here it is HC. There are two identical groups, opposite side. Two identical groups on the same side. So this is cis isomer. This is trans isomer. Yes, it shows. So now you understand how to do it, right?
Yes, doctor.
Okay.
Yes.
What about hex 1-ene? Does it show? Hex 1-ene. Hex 1-ene is what's the formula? 1, 2, 3, 4, 5, 6. 1-ene is this one. Sorry, CH2. Okay. CH2, 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 CH3. Does it show? Does this show?
No,
No. Why?
there are three.
Because, yes,
Other
because see here H, here H, here H, and here this group. What is it? CH2, 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 CH3. See, three groups are the same. So it will not show. Okay, understood?
Yes, doctor.
Yes,
Yes.
yes.
No. I don't know whether you remember this or I just mentioned these names before. You know, the types of attacking species. One is free radical. Do you remember free radical we did already?
Yes.
Another one is nucleophile. Next one is electrophile. Okay, nucleophile, electrophile, and what's the other one?
Free radicals.
Free radicals. Okay, free radicals I already finished. Now we have nucleophiles and electrophiles. Okay, so now here, the term itself, it's clear. You know what nucleus is. What is nucleus?
It's at the center of the atom.
Yeah, center of the atom. No in Arabic, right? Correct?
Yes.
Okay, so center of the atom, what's the charge of the atom? I mean, sorry, center part of the atom, the nucleus. What's the charge of the nucleus? Do you remember?
Neutral.
Nucleus is neutral. Nucleus
No,
contains.
no, sorry, not neutral.
Positive.
Positive.
Yes, nucleus is positively charged. Okay, so nucleophilic means loving. So nucleophilic species means nucleus loving species. You know, like charges repel, unlike charges attract. So nucleophilic species or nucleus loving species will have negative charge, right?
Yes.
Nucleus is positively charged, right? So nucleus loving
Yes.
species should have opposite charge.
Yes.
Right? Okay. You know the charge of electron, right?
Yes, it's negative.
Negative. So that means, see, here in nucleophiles or nucleus loving species are electron rich species. Okay, they are electron rich. That means either they have a negative charge, but sometimes even though they don't have negative charge, they can act as nucleophiles because if they have lone pairs. Lone pair of electrons on the central atom. Did you understand? Did you get the points? So nucleophiles are electron rich species. Either they have a negative charge, see Cl minus, Br minus, OH minus, okay? And here Mafic charge, but it has a lone pair. See, look here, this is alcohol, C2H5OH, it has 2 lone pairs. In the imtahan, I will not give you the lone pair, so you need to know that, okay? Sorry, you understood what I meant? Look, dears. Suppose if I ask you, CH3NH2 is it a nucleophile or electrophile? So in this case, you need to know that nitrogen has a lone pair. Do you know how it is? Do you know? You please tell me. We have CH3NH2, right? Right?
Yes.
N is from which group of the periodic table?
5.
5.
5.
How many valence electrons it has?
5.
5.
So how many electrons we used already? Nitrogen.
We use 3, so there's 1 lone pair.
There is a lone pair. See, like that you can find out. This is a way to do it. Okay? Understand?
Yes.
Okay. So now, next, electrophiles. Electron-loving species. So it's opposite. Electrons are negatively charged. So electron-loving species are maybe positively charged. So they are electron deficient. Understood? Just opposite. Nucleophiles are electron-rich species, and electrophiles are electron-deficient species. Okay. Then either they have positive charge. So here in the other case, either they have negative charge or neutral species having lone pairs. Now here in this case, it's opposite. It's positively charged. Okay. Or neutral species which are electron deficient, means less than 8 electrons on the central atom. Look, Cl plus, it's obvious positively charged, so it's electrophile. NO2 plus, Br plus. Now look at the BF3. BF3, come on, how do you know it's electrophile or nucleophile? See, my dear, draw BF3. Boron is in which group of the periodic table? So, you know, just before, during the exam time, you can keep one, what do you call, periodic table with you, okay?
Yes.
Yeah, okay. So now, most probably your exam, I forgot to tell you that exam with camera switched on through Teams. Exam will be through Blackboard, but then I want to see you, okay, with camera switched on, right? Okay?
Right.
Yeah, okay. Now, so you can have a periodic table with you at that time. Okay, so boron is, you have periodic table, you can get it from the net, right? Okay.
Yes, doctor.
Boron. Okay, boron is from 13th group. How many valence electrons it has?
3.
Okay, so is there any lone pair on the central atom?
No.
No.
Around boron, total how many electrons are there now? Total electrons, not the valence electrons.
6.
6 electrons. 6 electrons means less than 8. You understand what I meant? Electron deficient. AlCl3 again. Al also is from group number 13. So it has three valence electrons. So no lone pair. And how many electrons are there around aluminium?
Also
6.
So it is electron deficient. So now I hope you understood. Okay.
Yes.
Okay. Yes. Now. So just like the other thing I told you, intermediate carbon compounds, you know, during a reaction, sometimes intermediates are formed. Understand the meaning, okay? So the intermediates formed in a chemical reaction, it can be carbocations. Carbocations means the term itself, it's clear. You know what are cations? What are cations?
Positively charged.
Positively
Ion.
charged. So carbocations means carbon with positive charge. Understand?
Yes, doctor.
The other one is carb anions. Carbon having
Negative charge.
negative charge. And of course, all of you know, free radicals, carbon with a free radical. So here, carbocation, say CH3 plus. The carbocation, CH3, say CH2 minus. Free radical, CH3 dot. I hope you understood. Okay, so this is the meaning of carbocation. Carbon having positive, carbon having negative, carbon having a free radical. Now, about carbocations. See, carbocations are those species having, of course, positive charge. And how many electrons will be there? 6 electrons. See, look at these cases, examples. Did you see these examples? This one, this particular one, first one. This one has 2, 4, 6. Look at this one. Here it is 6. Here it is 6. All of them 6 electrons. Okay, understood?
Yes. Is it always 6?
Yeah. All that's why in a carbon means it's like after forming 3 bonds, if it is losing 1 electron, then only it gets positive charge. So all cases it will have 6 electrons. Okay. Total electrons around it, the bonded electrons, I mean. Okay, not the valence electrons. Carbon can have valence electrons of carbon 4. Okay.
Yes.
1 electron is gone, so it will have 3 electrons. With these 3 electrons, it can form only 3 bonds. Right?
Yes, doctor.
3 bonds means total 6 electrons. Okay. Okay.
Clear.
Now,
Yes.
this is again very important when we do mechanisms later on. These points are very important. That's why I'm giving these are just introduction part of the lesson. Okay, listen. We have 4 different types of carbocations. You can see from the screen. First one is methyl carbocation. Can you see? CH3 group plus positive. This is a primary carbocation. That means we consider this one as alpha carbon. I mean, carbon with positive charge is attached to 1 alkyl group, so it's primary. Since it is attached to 2 alkyl groups, it's secondary. Since it is attached to 3 alkyl groups, it's tertiary. Is it okay? Understand?
Yes, doctor.
Okay. Now, here, something written here, most stable, least stable. Did you see?
Yes, doctor.
Yes, doctor.
The most stable one is the tertiary carbocation. Least stable one is methyl carbocation. See. Now, dear students, listen. If we have a carbocation or a carbanion or a free radical, the stability of those species depends on the charge distribution. Okay, among these free radicals are not having charge. So, okay, leave it for the time being. And the other two, that means one with negative charge or one with positive charge. If there is distribution, delocalization of the charge, it will be highly stable. Whereas if charge is intensified, it will be highly unstable. Did you understand something?
Could you please repeat, doctor?
Look here, my dear. See, look, look at the tertiary one. I will take a pen, okay? Say CS3, CS3, CS3 positive. Okay, now I have another one, CS3, CS3, CS3 negative. So this is a carbanion, right? Correct?
Yes.
Yes.
This is a carbocation. Carbanion has, okay, leave that. Okay, so now look here, dear. There is something called inductive effect that we didn't do, okay? Inductive effect means electron releasing effect. And one more point is there, hyperconjugation. But it's like that is too much chemistry, so I don't want to teach that hyperconjugation now. Oh, sorry. Okay, okay. Hyperconjugation is another term, another process. Okay, you don't need to know that hyperconjugation, but then without I can't neglect this. That's why I just introduced that term. Look, inductive effect means electron releasing effect. Okay. Alkyl groups are considered as electron releasing groups. So that effect is called inductive effect. Okay. Now I will explain it, don't worry. So this CS3 is an electron releasing group. It releases electrons. It gives electrons. Electron density. That means the electrons are going closer to that one. This one also is electron releasing group. So if there is any charge here, if whether it is positive or negative or whatever, if this is increased by any chance, if you increase its intensity, it will be highly unstable. Whereas if it is distributed everywhere, it will be stable. You understand or not? Did you get something or you got confused? Did you get confused?
I'm a little confused.
Okay, see, I will give you another example because I don't know the Arabic terms for distribution and intensification. Okay, I'll give you one this thing. See, suppose, just imagine, you have it's just only imagination. Okay, for one exam. So suppose you have 3 tests. Okay, test number 1, you got less marks. Just imagine, you will not get less. Okay, I'm just simply telling. Okay. Somebody, not you, somebody else is getting first test less marks, second test less mark, third test less mark, all the tests less marks. So what about the condition of that student? Too much intensification, right? Negative thing is too much. So he will be in a highly unstable condition, right?
Yeah.
Okay, whereas suppose, okay, one test, suppose he is getting less marks, other 2 tests he is getting good marks. So what will happen? One, the effect of one is distributed or it is compensated by the other. Understood what I meant? One test, one quiz less marks. So that is this positive charge. One quiz you are getting less marks, it's positive. Okay. Okay, so now these are exam number 1 very good marks, exam number 2 very good marks, exam number 3 very good marks. So effect of this one is less now. Your marks will be overall marks will be very good. Understood now?
Yes, doctor.
Okay.
Yes.
Okay. It's a lame like example, but I don't know the Arabic, that's why. Okay. So now here the problem is what? Positive charge, right? Somehow if you decrease this positive charge, it will be stable. Now it's clear for you?
Yes, doctor.
Yes. Okay. So now CS3 is releasing group. Electron releasing group. What's the charge of electron?
Negative.
Negative. So this negative will partially cancel this positive. Correct?
Yes.
Okay. This CS3 also is releasing. So it will partially cancel the positive charge. This one also is releasing electrons. So it will partially cancel the positive charge. So the intensity of positive charge will be less. Is it clear?
So it's less charged than
yes,
the
less charge. So
cation.
yes, that means charge is distributed or compensated. Okay, you see, we will go for this one. So you will understand the next one. Suppose if it is a carbanion. See, in this particular case, this one. Second one. What is the problem here? Which charge?
It's negative and methyl is
yes, methyl is electron releasing. It gives electrons. This gives electrons. This gives electrons. So the intensity of negative will be
higher.
High. So it's less stable or more stable?
Less stable.
Less stable. That means quiz 1 less marks, exam 1 less marks, exam 2 less marks, exam 3 less marks. His condition gone.
So carboanions are the opposite of carbocations
Opposite,
for the
yes.
stability.
Yes.
Okay.
Stability. Okay, understood now, right?
Yes.
Okay, so now here, so tertiary carbocation is the most stable one. You tell me the reason for that.
Because the electrons released from the methyl groups partially cancel the positive charge.
Yes.
on
What
the
about
carbon.
the secondary? Why is secondary less stable than tertiary?
Because only 3 methyl groups.
Only?
Only 2, sorry.
Yes. Okay, so here we have 2 methyl groups. In this case, here 2 methyl groups. Okay, this case only, come on, 1 methyl group. Here no methyl group. So this is more stable. Tertiary carbocation is more stable. What's the reason for that?
Because of the distribution of the charge.
Yes, positive charges.
Partially cancelled by the
Okay.
electrons.
Partially cancelled. Or in bracket, distributed. Okay. Distributed. Okay. By the electron releasing effect of three alkyl groups. Electron releasing effect is called inductive effect. Okay. Okay. So now here it is minimum intensification. Distribution of the positive charge is minimum. Other case, distribution of the positive charge is maximum. Tertiary carbocation is the most stable carbocation due to actually one more point is there. What is it called? Hyperconjugation. That's too much chemistry. Okay, I don't want to teach that. Okay, it takes time again. Okay, so since you are not a chemistry major student, you don't need all those. Okay, this you understood, right? This much, it's okay.
Yes, doctor.
But everyone understood, only Rahma understood?
Understood.
Everyone understood, right? Okay, all are clear, okay.
Yes.
Okay, now, chemical properties of alkenes. Do you know, dear students, we have, in alkenes, we have pi bond, right? One sigma bond and one pi bond. And this is sigma and this one is pi. You know, when compared to sigma bond, pi bonds are
Weaker.
So it can be broken down easily. Okay, you know why pi bonds are weaker?
Because of the lateral
Yes, because of the lateral
binding of the
okay, now look here.
orbitals.
See, yes, addition of halogens. So the double bond will be broken down. Double bond means the pi bond will be broken down. We will add something. Do you remember last class I told you we have different types of reactions: addition reaction, substitution reaction, rearrangement reaction. Like that, different reactions are there. So alkanes undergo substitution, but alkenes can undergo addition reaction by breaking this pi bond. Now we are going to add halogens. Halogens means mainly we add chlorine. Okay, chlorine in presence of CCl4. CCl4 is a solvent. Okay, so just to make a mahlul, or bromine in CCl4. Okay, we don't do iodine also because iodine is the least reactive one among them. Okay, or Br2 in CCl4 solvent. CCl4 has no role, it's just a solvent. So of course you know the products. We break the bond, right? And what do you get? Tell me. My dear students, come on. What will happen? This bond will be broken, right?
So it will be CH2Cl on both sides?
See, this bond will be, yes, one Cl here, other Cl here. So what's the product?
CH2Cl.
Single bond CH2Cl. What's the name? What's the name of the compound?
Yes.
Yes, 1, 2. What's your name, my dear?
Aisha.
Aisha, okay. Okay, now next one. Next one of the boys, you tell. Come on. Boys are not here in the class.
With you, doctor.
Yeah, tell me.
1, 2.
Okay, so I will break this bond. One Cl goes here, another Cl goes there. So what do you get? CS3?
CH2, CHCl, CH3, Cl.
CH3 or CH2?
Sorry, CH2.
Okay, the name?
1, 2, dichloro
Propane.
Propane. Now, when it comes to this one, bromine, there is a speciality. It's reddish brown in color. Okay, and it's not actually, these things are not good for the health. So usually when we do these experiments, we do this thing in the fume cupboard. Okay, it's not good to inhale this chlorine or bromine vapor. Okay. Now, CH2 double bond CH, CH2, CH3, similar reaction will occur. So what are the products? Tell me. What do you get? CH2, single bond CH, CH2. Okay, and then, come on.
And bromine in the first and the second carbon.
Yes. Now, next one. What about the next one? How many double bonds? Yes, it is CH2, single bond CH.
CH2, CH2.
Okay.
Here I'm not sure.
Here, but it's okay, just normal. There are 2 double bonds you break. One Br here, one Br here, correct? Similarly,
Yes.
this one also Br, this one is Br, that's it. No,
We
the
have
special.
only 2 brom.
Yeah, only have 2 bromine.
No, I didn't
atoms, so
balance it, my dear. I didn't balance it. Of course, you can add 2 Br2 here. Organic reactions, even if you don't balance, especially except combustion reactions, it's okay. We don't write any of the things balanced, no? Okay, so now, okay, if you want to write balance equation, no problem, you can add 2Br2, okay? Now, the speciality of this one, I told you, this compound is colorless. This compound is also colorless. What is the original one? What's the color of bromine?
reddish brown.
Brown. So this can be used as a test for unsaturation. Did you understand?
Yes.
Yes, doctor.
Yes.
Test for unsaturation. What do you mean by unsaturation?
Double bond.
Double bond and triple bond.
Triple.
Not just double bond. Okay. Yeah. There is no. I'll just make an empty slide. Okay. To explain.
So if it turns from reddish brown to colorless, then there's a double bond?
Yes. Even not only double bond, even triple bond also. Okay.
Okay.
See. Suppose if you have one compound is CH3, CH2, 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 CH3. This is an alkane. Okay. This is CH2 double bond, CH2, CH3. So one bottle you have this alkane, the other bottle you have alkene. You cannot see both of them. So you want to find which one is alkane, which one is alkene. So what you have to do is take alkane in one test tube, the other alkene in the other test tube. So now both cases you add Br2 CCl4. You understood what I meant? Okay. So
Yes.
this is alkane. This is alkane. This is alkene. You tell me the observation. What will happen? What will happen?
In the alkene, it will remain
Yeah.
reddish brown, and in the
Yes,
alkene, it will become
remains reddish
colorless.
brown. Here it will be colorless. So the vessel where there is no color is alkene, and vessel where there is color is alkene. Now this is not only for alkene, even for alkyne also. Suppose if it is CH triple bond CH or anything, I write R. So in this case, what is it? When you add bromine in CHL4, this also will become colorless. So alkenes and alkynes give this test, bromine test. Alkenes do not give this test, okay? So you can distinguish alkene from alkene and alkyne. You can't distinguish alkene and alkyne by this test. Why?
Because it will have the same outcome.
Yeah, both of them will give same. Okay, that's it. Now, till now I was talking about the addition of halogens. Okay, this similar reaction will occur for cycloalkenes also. I just wrote only alkene here, my dear. Instead of alkene, it can be cyclopropene, cyclobutene, cyclohexene. So the same reaction will occur. Okay. Yeah. Okay. Now. Next is addition of H2O, addition of H2O in presence of an acid catalyst. Okay, this process is called hydration. What is it? Hydration. Addition of H2O is called hydration. Okay, and then this is taking place in presence of an acid catalyst. Say small amount of sulfuric acid or something will be added. So H2O means you can split as H and OH, right?
Yes.
Okay, so here, tell me now. Are you here with me? H2O, H plus and OH minus. So here say H, here say OH. So the product will be CH. Tell me.
3. The single bond C H2OH.
Okay, so this is called ethanol. So that means alkene to alcohol. This is one of the methods to make alcohol. This one, can you tell me the product?
We will have 2 products.
Ah, good. What are the 2 products? Say, let me write this first. Tell me about the products.
We can get proper 1 all. Proper 2 all.
Yes, you agree. Do you agree with him? You are Safwan, my dear?
Yes.
Okay, so it's H plus and OH minus. Okay, so here there are 2 possibilities because this is an unsymmetrical alkene, right? You understand the meaning of unsymmetrical and symmetrical? In the first case, across the double bond, both are same group. Here, not same group. Okay, left side of the double bond and right side of the double bond groups present are different. So now here, 2 possibilities. One case I can put H here, OH here. Other possibility I switch OH here, H here. Okay, you understand the meaning. So first case CH3, CH2, CH2OH. Second case CH3, CHOH, CH3, of which this is formed in minor quantity, or we neglect this, very small in amount. This is major quantity. This is the main product. So propane 2-ol. This is propane 2-ol, right?
Yes.
This is propane 1-ol. This is in accordance with I wrote some rule. When H2O, this rule is not really applicable for H2O, even HX. HX means it's HCl aqueous, HBr aqueous, HI aqueous is added to an unsymmetrical alkene. Actually, it is not just for alkene, even for alkyne also. Okay, we will do the same rule for alkyne. The negative part, that means the OH minus or X minus, in the case of HX, X minus, gets attached to the carbon atom containing less number of hydrogen atoms, or hydrogen goes to the carbon atom containing more number of hydrogen atoms. Did you understand, or do you want me to explain?
No, it's clear.
Explain.
Okay, I will explain. Maybe some people it's not clear. Look here. And then with this I will explain. CH3, CH, double bond, CH2. Okay, all cases addition takes place over here. Just focus only here because the double bond is present there. Now on this carbon, we have Vahat hydrogen, one hydrogen. Here on this next carbon, how many hydrogen atoms are there? Two hydrogen atoms. So this is less number, this is more number. Okay, so the rule is you can just write with respect to H plus or write with respect to OH minus. H plus goes to the carbon atom which contains, come on, more number of hydrogen atoms. So H comes here. H goes to the carbon containing more number of hydrogen atoms. And if H goes there, OH will come here. So the rule is OH, the negative part will go to the carbon which contains less number of hydrogen. Or if you want to tell the other rule, any one is okay. H will go to the carbon which contains more number of H. So what is the product here? You get CH3, CHOH, CH3. Did you understand?
Yes, doctor.
Okay. See.
Yes, doctor.
Now I'll give you more examples later on. Okay. Okay. With this type, I can give you more examples. It's coming later on, more examples. Okay. With HX, I will give you more examples. Or you want more examples here itself?
Whatever you
Yes.
want, doctor.
One example.
One more. Okay. See. Oh, sorry, H2. Tell me. Tell me the product. Yeah. Coffee product.
One methyl.
One. Don't tell one methane. One methyl.
One methyl.
Mm.
Cyclo.
Mm-hmm.
One.
Mm.
I forget the naming. But the OH will be the same carbon with CH3.
This one correct? Did
Yes.
you
Yes, because that carbon has only one H, and the other one has two H.
No, that carbon no HDN.
Where? Oh, okay,
And,
okay. It's connected to the other carbon, sorry.
yes. Do you want me to explain it? Anybody
Yes,
else?
please.
Okay. See, I'll explain. Look. Okay. Each one is a carbon, right? Each junction is a carbon. Here, carbon. Okay. This carbon is already linked to 1, 2, 3, 4, right? Correct? Correct?
Yes.
So there is no hydrogen on this carbon, 0 hydrogen. Whereas this carbon is linked to how many? 1, 2, 3. So how many H are there? There is one
One.
H. So 1H. So when you add, you will add hydrogen. You are adding one side. We will break this bond. One side you will add H. The other side you will add OH. So H will be added to the carbon which contains more number. So 1 is more than 0. So you will add H here, OH there. Or you got more confused? Or you understood?
Understood.
Understood. Okay, fine. Now, more examples are coming. Don't worry. Even if you have doubt, it will be cleared. Now, we add HX. HX means HCl, HBr, HI. So, can you tell me the products first case? This is here, no issue.
This one is symmetrical, so there is no.
Same, symmetrical, so does not make any difference if you put at this side or left side or right side. You get the same answer. Okay, tell me the products.
CH3.
CS3.
Single bond.
CH.
CH2Cl.
Okay, next one CS3, CH2, Br. Correct?
Br.
Next one CS3, CH2,
CH2I.
Now, when it comes to this one, I didn't write this part because it's the same. Here, this is now this is unsymmetrical, so you need to apply which rule? Markovnikov's rule.
Markovnikov's rule.
Okay, so now here, how many hydrogen? You want me to explain with hydrogen or with respect to Cl?
I don't know. Both of them are the
Okay.
same.
Yeah. So here, how many hydrogen atoms are here? 2. Here, how many hydrogen atoms are there? 1.
1.
So this number is less. This number is more. So you are adding H and Cl. H will go to the carbon which contains more number of hydrogen.
Yes.
Right? Okay. So H comes here, Cl comes here. Okay for everyone now?
Yes, doctor.
Okay.
Yes,
so
doctor.
what's the answer now?
CH3.
CH.
CH2.
CH3, CH, single bond, CH3, right? I didn't write the middle portion. I will use a different color, okay? That's why I'm not writing now. Okay, so I can write here Cl. Here I can write Br, or we can write bracket. Here you can write I. This is which rule?
Markovnikov's rule.
Okay.
Yes, doctor.
Now tell me this one also. We will finish off these two. Oh, that's a mistake.
Symmetrical, so it's okay, right?
There's a mistake there.
Where?
In the first case, there is no H. Okay, now tell me.
CH3.
Yeah.
Single bond.
This one has how many hydrogen? 1, right? This one
That
has
one
how
has
many hydrogen?
no hydrogen.
So where H will go?
H will go to CH.
Okay, yes.
And the iodine will go to the second.
Product
CH3.
C,
CI.
CH2, CH3, and I goes to
The one with the C only.
okay. Now this one, come on, this one.
The BR will go with the CH3 and
yes.
H will go to the down.
Yes, very good. So Br and CH3. Okay.
Yes.
Now, so this rule is over now. We have to do why. You didn't ask me why. So we will do the mechanism next class. Okay. Why is it so? Markovnikov's rules mechanism will be done next week. Okay. Study well for the exam. Please don't wait till the last moment. Okay.
Inshallah.
Yeah. Okay. Okay. Bye bye.
Thank you, doctor. Have a nice day.
Yeah, you too. How many are here? Let me check. Oh, only very few students attended. Okay, fine. Okay. Bye.